Hey guys, this video is about CLT. It's a key component of statistics in which we utilize to help us to basically use the Z-score when things are skewed. Because remember, we've always established we are always trying to make things normal, as I do my little quotes, normal. Okay, so here, as you see that I have right here, this is at the bottom of page 12, but I changed it. I just didn't like it. So sorry, you're going to have to put another sheet there. But as you can see here, most populations are not approximately normal. So what is the whole point? That most of them are skewed. And as we stated before, it's reasonable that if we have a skewed population, then we're going to get a skewed sample. But the miraculous CLT states that if we take an SRS from a non-normal distribution, even something that's extremely heavily skewed, then that the sample distribution, which is X bar, will become approximately normal as long as we have that sample size of n is greater than or equal to 30. Okay, so that means that our sample mean is going to look like that of the population. And then, of course, we have a new standard deviation in town. So, restating CLT, we use that if we have something that is skewed. And if it is skewed, CLT said, okay, I got you. You might be a little off, but I can help you because now I'm going to get a big enough sample size. So even though you might be a little jacked up, I can make you look normal. That is what CLT does. Now, we talked about this before, in which if we have a normal population, of course the samples that come from them are automatically going to be normal. Okay, as I just do that really quickly and just rush down to a big amount. Okay, well, it was normal. It started off normal, it comes out normal. Okay, now, what about if I clear this and I go to a skewed population? And I need to correct something I said before. I did say that if it starts off screwed up, it comes out screwed up. And I did say that it is possible to be skewed and come out normal. Okay? But I wanted to clarify that the reality is that this is true, again, with the idea of the sample size being greater. And I know I said that, but I'm thinking that there was one class that I didn't clarify that in, so I just wanted to do it. So we know here, okay, if this is your sample, okay, that's very small. But if I just click on that, look at this now. This looks approximately normal. In addition to that, if we look at this part right here, look at your mean and your median. Okay, your mean and your median, they're approximately equal. And remember, when you have X bar is approximately the same as your median, that means that they are approximately symmetric. I'm doing this with my hand so you can see how sloppy that is, sorry. And you can see up here how they're showing you that it is starting off skewed. Because again, as we look at our mean, compared to our median, and since we have it going in that direction, and look at our value for X bar up here. Our X bar is your 8.08. Your median is your 7. So this is just, remember, an equation that confirms. Let's look at another distribution. Let's clean this up and start from scratch. Okay, so showing you once again, just using the same skewness that we've got going on here. And I already see that I didn't change in any. I still have the same mean and median there. But let's look at this distribution here. Just a second. Why is it freezing on me? Let me stop for a second, guys. Okay, so here as I just click on, here's 5, we can see how skewed that is. Even look at your mean versus your median. So yeah, it is skewed, not heavily skewed, but it is slightly skewed. Look at your mean is greater than your median. Look at my arrow, just like it is here. But if I go with, again, 10,000, here, your mean is slightly greater, okay? But I could say that, and look at the shape though, it looks approximately symmetric. And then of course if we do that, look here, our mean is 810 and our median is 8.10, and here is 8. We should have checked out the standard deviations in these prior ones too. Look at the standard deviation up here, and then look at the standard deviation down here. And here it tells you have the number of reps that we have, tells you that it's extremely large. Now, I just hit the custom one and I just clicked on, and it's not working right now. I don't know why it's not working anymore, but I don't care. We've got these two right here. Look at your mean versus your median. This looks like it's approximately normal. And if I click on just 5 of them, yeah, that mean and median, as you can see right here, is pretty reasonable. Okay, but what happens if I go to 10,000? Look at that mean and that median. Okay, so here, even though this was, I should have made a better, it really wasn't that skewed. It did come from I want to say approximately a pretty symmetric, so therefore we can assume approximately normal population. But let me attempt to make a left skewed distribution. Okay, I found out how. I'm just taking it and pushing it up, pushing it up, pushing it up. Just dragging just a tad. I think we'll all agree that's pretty, that nice staircase I got going on there. Looks pretty left skewed. Now let's look at our mean and our standard deviation up here by my arrow. And let's of course look at our median. Now let's look at our, let's do, no time for animation. So here, look at the difference between our mean and our median. So our mean is bigger than our median, so the skewness is the same. Okay, let's make it 10,000. Here, our mean is slightly bigger than our median, and let's make it 100,000. Okay, and are my eyes deceiving me that it looked like it was farther away? Okay, so here's with the 10,000. Here's with the 100,000. Okay, and the reality is, if I go with 10,000 or 100,000, it really doesn't seem to matter. It is large, and that's the whole premise. And yes, it does, as CLT states, the bigger your sample size is, the closer the sample mean approaches the population mean. Now, here are a few more notes I wanted to add, so you just need to get out another sheet of paper or add it somewhere in the existing packet, because we won't be writing up any more notes, so you can just get a piece of paper. We already talked about this part in terms of the population not being normal. I just needed to clarify the difference in these rules. Okay, the large count condition, the basic thing that we're saying here is that, okay, it is safe to use a normal approximation, which means z-score, if these two are applicable, if these two criteria are met. But in addition to that, it also tells us if a sample size is too large. Okay, I'm sorry, if a sample size is too small. The other one is too large. So let me restate that. It also states that you have a sample size too small. Think about the logic on this. If it's too small, you can't use a normal distribution. So that makes sense, and it shows how the two of those work hand in hand. The law of large numbers is saying that as the sample size increases, the distribution starts to become approximately normal. Well, isn't that exactly what we kind of said up here? And if you notice, the consistency is, it is all about a large sample size. Larger and larger, the more it looks like a normal approximation. And don't forget, you just can't say normal. It's got to be approximately normal. Lastly, which I just talked about, which is CLT. CLT states that as the sample size increases, that sample distribution X bar starts to look like the population mean. So, and isn't that something that we wrote down before, in which we said that the mean of the sample is equal to the mean of the population? Because that's all the CLT is saying here. As your sample size goes up, then this is what's going to happen. And then the last thing I wanted to clarify and remind you of, the 10% rule. The whole purpose for the 10% rule, we've stated over and over again, is to make sure our sample size is okay. But I need to clarify, the whole premise is that sometimes we take too large of a sample. Here at our school, at Awanda, we have approximately 3,400 students. So let's say that I told you guys for your project, you had to go out there and get 3,300 students to do an experiment or a survey. First of all, you'll think I'm on crack or something. Okay, but more importantly, is that a true sample? I mean, goodness, if you're going to get 3,300 students and it's a 3,400 population campus, wouldn't you just get the census and get it over with? And that's the whole premise behind, if the sample is too large, then it's not truly a sample. So that is the difference between large count condition, law of large numbers, which are interchangeable in my opinion, CLT, and the 10% rule, or 10% condition. Okay guys, have fun doing your homework.